Hey everybody, today's lesson from Unit 2.2 is about similar polygons. Two polygons are similar if they have the same shape, but they're different sizes. So in other words, two squares could be similar to one another, two triangles could be similar to each other, two hexagons could be similar to one another. They have to be the same kind of shape, but they will be different sizes. And proving that they're similar is a little bit more specific than just saying they have the same shape. We can say that two polygons are similar if their vertices can be paired so that corresponding angles are congruent and corresponding sides are in proportion. In other words, when you compare all the pairs of corresponding sides, you have to get the same ratio every time. If you get even one ratio that's different than the others, then your two polygons are not similar. So for example, if you take a look at these triangles, notice that angle B in the small triangle is marked congruent to angle E. Sorry about that. Angle C is marked congruent to angle F. And angle D is marked congruent to angle G. So far, these two triangles satisfy the first part. Corresponding angles are congruent. The next thing we have to take a look at is the way in which the sides compare to each other. So check it out. BC is 5, and it corresponds to EF of 10. And that ratio reduces to 1 over 2. Check out CD, which is 3, and FG, which is 6. So that reduces to 1 over 2. So far we have the same ratio. Last pair of corresponding sides, BD is 4, and that corresponds to EG with length 8, and 4 over 8 also reduces to 1/2. So since all three of these ratios are the same, we say the sides are in proportion. This ratio, by the way, is called the scale factor for the two figures. Notice that the little triangle is half the size of the big triangle. Finally, once we determine that two polygons are similar, we can write a similarity statement for the two triangles. So let's start by naming the first triangle, triangle BCD. And we say it's similar to triangle, and the second triangle would have to be named EFG. They have to be named so that the congruent angles line up and so that the corresponding sides are proportional. And check out that symbol for similarity. Just a little wavy line like the top of a congruent symbol. In question number 1, we're given that quadrilateral MNOP on the left is similar to quadrilateral M'N''O''P'. The first question asks us to find the scale factor of the two quadrilaterals. And again, we have to do this in order. We're comparing the smaller one to the larger one. So this means that the side MN corresponds to M'N', in the same way that NO corresponds to N'O', in the same way that OP corresponds to O'P'. And that would also be equal to MP over M'P'. So if we take a second and we're going to plug in everything we know from how it's labeled in the picture, our ratios will look like this. Mn is equal to x, so that will be over M'N', which is 15. It's going to be equal to NO, which is 18, over N'O', which is 27. That's equal to OP, which is 28, over O'P', which is Y. And this is equal to MP, which is 24, over M'P', which is Z. Now if you notice in here, every fraction, except for 1, has a variable in it. this one fraction without a variable is going to be our scale factor. But we don't want to list the scale factor as 18 over 27. You need to reduce it. So take and divide both 18 and 27 by 9. We get a scale factor of 2 to 3. So it's the scale factor that we're going to use to solve for x, because we don't want to go back and work with 18 over 27. So to find x, take your scale factor, 2 over 3, and then set it equal to the fraction that has x in it, x over 15. Cross multiply, we end up with 3x is equal to 30. Divide by 3, we get x equals 10. Okay, to solve for y, take your scale factor of 2 over 3, look for your ratio that has y in it. We have 28 over y. Cross multiply, we end up with 2y is equal to 84, because that's what 28 times 3 is equal to. And then take and divide by 2. 84 divided by 2 gives us 42. Finally, to solve for z, take your scale factor of 2/3 and set it equal to your final fraction, 24 over z. Take and cross multiply, we end up with 2z. So I just erase that little equal sign. We end up with 2z is equal to 72. Then take and divide by 2, we get z is equal to 36. So I'm just going to take a second and put those numbers in here. So this is 36, we found y to be 42, and we found x to be 10. I'll just put an arrow there. Okay, the last question in here says we want to compare the perimeter of the first figure to the perimeter of the second. The perimeter is just the distance around the figure, so add up all the side lengths. So in the figure on the left, we have our side of 10 that we just found, plus 18, plus 28, plus 24. When you add those guys together, you end up with a perimeter of 80 units. And now we're going to compare this perimeter to the perimeter of the larger figure. So for the larger one, we have to add 36, 15, 27, and 42. And those total 120. So if we're comparing 80, I wrote 8, so let's fix that. If we're comparing 80 to 120, something interesting happens when you reduce it. Of course, I can take it down to 8 compared to 12 just by dividing by 10. Simplify one more by dividing by 4, and we end up with 2 to 3. Now, that should sound familiar because 2 to 3 was our scale factor in the beginning. It's not just a coincidence. This is always going to happen. Whatever the ratio is of a pair of sides in similar figures, the ratio of the perimeters of the figures will always reduce to that same fraction. Okay, in questions 2 and 3, we're told that the two figures are similar, and we have to solve for x and y in each problem. So, in number 2, you can see that the side length of BC, that's labeled with x plus 4, corresponds to the side length of EF in the second figure, because you can tell by the angle markings there. And that's going to be equal to the side length of 21 over 14. So this is what I want to use to solve for x. So first I'm going to take and reduce this fraction of 21 over 14 by dividing by 7, and I get 3 over 2. Then we'll cross multiply. So let's move this up a little bit. So we're going to take 2 times the quantity of x plus 4 and set it equal to, there's a 4 in there, set it equal to 6 times 3. So distribute, we get 2x plus 8 is equal to 18. 2x is equal to 10, so x is equal to 5. Now, this fraction, 21 over 14, reduced to 3 over 2, and that's our scale factor. That's going to make it a little bit easier for us to solve for y. So take your scale factor, 3 to 2, And now set it equal to the ratio of 15 over y, because that side length of 15 in the first triangle corresponds to y in the second triangle. Remember, in this case, I'm always comparing the big triangle to the small one. You have to keep it consistent throughout the problem. Cross multiply, end up with 3y is equal to 30, and then divide by 3 and we get y equals 10. Okay, for our last example, we're comparing these two quadrilaterals. Again, all the corresponding angles are marked congruent, and we're told that they're similar. So this would tell us that y plus 2 corresponds to 5, in the same way that 18 corresponds to 4. Again, I'm comparing the larger figure to the smaller figure. Okay, so take and reduce that fraction on the right. Notice I'm putting the y plus 2 in parentheses also. So this fraction reduces to 9 over 2. Okay, cross multiply, we get 2 times y plus 2 is equal to 45, because that's 9 times 5 along that diagonal. So 2y plus 4 is equal to 45, or 2y is equal to 41. When you divide by 2 in this case, you're going to end up with 20.5. Remember, it's okay to get a decimal or a fraction as an answer. Okay, remember that this fraction, 9 over 2, is our scale factor, comparing the big quadrilateral to the small one. And now we're going to use that 9 over 2 to solve for x. So here's x, and here's 3 that it corresponds to. So 9 over 2 equals x over 3. Get 2x is equal to 27. Divide by 2, and again we get a fraction. Well, in this case I'll write it as a decimal. 27 divided by 2 is 13.5. Okay, good luck on the CYU, and make sure you ask questions if you need some help.